Okay, so in the last class, I think this is the last problem which we have discussed in the last class. That means on Monday. This was the last question which we have discussed in the last class. Yes? Is it? I think it is the last problem. Okay. So today we are going to discuss about the next problems, next type of problems. Okay. So let us see the next problem. Okay. So all of you please see the screen next. Next, all of you please see the next question. Okay. So the question is reinforce. All of you, I think all of you can read the question. Example 4.5. You can read the question. Example 4.5. A reinforced concrete slab 150 millimeter thick is reinforced with 10 millimeter diameter bars at 180 millimeter center to center. The reinforcement is located at an effective depth of 125 millimeter from the top. Calculate the moment of resistance of the section. Use M20 concrete and Fe 415 steel. Okay. So now, can anyone tell me what is the meaning of this 120 millimeter thick and 180 millimeter center to center? What is the value of this 150 millimeter? 150 millimeter is what value? 150 millimeter is what value? Which parameter is given? 150 millimeter. 150 millimeter total depth. 150 millimeter total depth. Okay. So any other answer? Anyone? Anyone have any other answer? What is 150 millimeter? Okay, to Achumi, can you tell me what is 150? Shiroda, can you tell me? Yes, good. It is the width of the beam. Okay, thickness means it is the breadth of the beam. Okay, Sheila, good. It is the width of the beam is given 150 millimeter. Okay, so next, how to find out the total means what is this 180 millimeter? What is this 180 millimeter? How can we use this value? Can anyone tell me how we can use this 180 millimeter value? Effective depth is given 125 millimeter. Okay, effective depth is given 125 millimeter. And can anyone tell me how to use this value 180 millimeter center to center? Anyone? Anyone have any idea how to use this 180 millimeter? Hmm? No. No, sir. Okay, okay. Okay. Okay, so read the question properly. A reinforced concrete slab 150 millimeter thick, okay, is reinforced with 10 bars at 180 millimeter center to center. Okay. Okay, everything is given. So here capital D will be 150. Okay, total depth is 150. Wilson Debarma, you are correct. Okay, so I'm sorry. Wilson Debarma, you are correct. Your total depth of the beam is 150. Effective depth is mentioned here, 125 millimeter. 180 millimeter is the spacing of the bars. Okay, and the diameter of bar is 10 millimeter. So from this, our diameter of one bar is given and the spacing is given. And from these two values, we can find out the area of one bar. Area of one bar we know, but total how many bars we are using, not actually how many bars, total area of steel, how much we have to calculate from these two values. Okay, so since the diameter is given, we can find out the area of one bar. This is the formula, pi by 4 d square. Then spacing is given, so therefore what we will do, we will see here, it is written we have to consider, say, for 1 meter width of the slab. Okay, so because the width of the slab, we don't know the actual width, total width we don't know. Okay, total width is not given, so what we will do, we will find out for 1 meter width. Okay, so for 1 meter width, how many bars will be there and what will be the total area of steel, that we will calculate. Okay, so for 1 meter width of the slab, 1 meter means 1000. So total area of steel will be, you can calculate by this formula. Okay, so this 180 is the spacing, 1000 means we are considering 1 meter width of the slab, and this is area of one bar. Okay, area of one bar, this is for 1 meter we are considering, and the spacing between one bar is, the spacing between two bars is given 180 millimeter center to center. So by this formula, this is a very simple formula. This is the width of the slab, this is our 1 meter, that is your 1000, into AST, area of one bar, 78.5, divided by spacing. Okay, if you do this, then you will get what you will get. You will get the total area of steel. Okay, AST. So after getting the value of AST, the remaining portion is exactly same with the last problem. What we have to do, we have to find out the depth of neutral axis, XU. Then we have to find out the value of XU max. Then we have to compare the values, and then we can calculate the moment of resistance. Okay. So after getting the area of steel, we have to calculate depth of neutral axis by this formula from IS 456 plus G.1.1. Then XU max will be 0.48D. Okay, from clause number 38.1. Then we have to compare the two values. If the section is under reinforced, then in this problem we are getting the section is under reinforced. So therefore, for moment of resistance, we will use this formula. Okay, MA equal to this formula. Okay, all of you, please go through the answer. If you don't understand anything, you ask me. Okay, if you don't understand anything, you can ask me. Hello. Do you understand this? All of you, do you understand this problem? All of you, is it clear? Okay. Okay. So I hope all of you have understood this problem. Okay. So let us see the next problem. I think it is the same problem. It is the same problem. Only finally you have to do. You have to find out the uniformly. You have to find out the UDL. This problem has been solved so many times. I think more than 2 times we have solved this same problem in working stress method. After finding out moment of resistance, what we have to do, we have to equate that value with maximum bending moment, which is WL square by 8, because it is a simply supported beam. So WL square by 8 equal to moment of resistance, and from that we can find out the value of uniformly distributed load. Okay. Okay. So this is, all of you try this. All of you try this now. All of you try to solve this problem now. Example 4.6. All of you please try to solve it now. Everything is given. You have to find out moment of resistance, and then you have to find out, what, then you have to find out the value of UDL, that means W. So find out the value. All of you try to find out and tell me the answer. All of you solve it and tell me the answer. All of you solve the question and tell me the answer. Anyone got the answer? Anyone got the value of XU? How to know that it is a simply supported? Okay, so normally if it is not given, if nothing is mentioned in the question, then you have to understand that beam is simply supported. Okay. In this kind of problem, say for moment of resistance, for this kind of problem, that means moment of resistance, if nothing is mentioned in the question, then you have to understand it is a simply supported beam. Okay. And if it is a cantilever beam, it will be specifically mentioned in the question. Okay. If the beam will be a cantilever, then it will be mentioned in the question. Otherwise, you have to assume that, or you have to know that it is a simply supported beam. Okay. Okay. Okay, so now all of you try to find out the value of XU. Anyone got the answer? XU 151.23. Okay, let me see the answer. 151.23. Yes, good. 151.23. Okay, so next you find out XU max. Find out XU max. Find out XU max. 192. Okay, 192. Yes, 192. So now what will be the type of section? Over reinforced or under reinforced? Under reinforced. Okay, so for under reinforced section, find out the moment of resistance. This is the formula. So anyone got the answer? Moment of resistance. Anyone got the answer? Moment of resistance, how much? In terms of kilonewton, you write down kilonewton meter. In terms of kilonewton meter, how much it will be? 73.28. Okay, 73.28. Okay, 73.28. Next, you find out the UDL. Find out the value of UDL. Span is given 5 meter. What will be the value of UDL, uniformly distributed load? WL square by 8. WL square by 8. Okay, 23.44 kilonewton per meter. Okay, so when is okay, your answer is correct, I think. Yeah, 23.45. 23.44 or 23.45, both are correct. So this is the final answer. Maximum ultimate load or ultimate load equal to UDL value is 23.45 kilonewton per meter. Okay, so let us see the next problem. Okay, all of you try this problem again. A rectangular beam is 20 centimeter wide and 40 centimeter deep up to the center of the reinforcement. Find the area of reinforcement required if it has to resist a moment of 25 kilonewton meter. Okay, so all of you please try this. If you can solve this, then your concept will be very much clear. If you have understood the previous problems, then you can solve it. If you can solve this question, that means you have understood the previous problems. Anyone got the answer? Anyone? Anyone got the answer? Anyone got the answer? AST. Okay, I will show you the answer. Okay, how to solve it. Anyone got the answer? Benison? Oinam? Shirodha? Anyone got the answer? Wilson? Anyone got the answer? Shirodha? Oketo Achumi? Wilson? Jeshila? Anyone got the answer? No, sir. Okay, so do you know how to solve it? I think previously in working stress method also we have solved a similar kind of problem. Where we have to find out AST, but moment of resistance is given. Can you solve this? Can you solve this? You tell me just that. If you say that we can't solve it, then I will show you the answer, how to solve it. No, sir. Anyone can solve this problem? Anyone? Because same problem has been solved in working stress method. Procedure was exactly same. Only the formulas were different. Only the formulas are different, but the same problem has been solved in working stress method also. First, what we have to do, we have to find out the depth of neutral axis. See this value. Okay, so these values are given. B is given, D is given. Then your M is given. Moment. How much moment we have to resist? It is given 25 kilonewton meter. Then FCK, FY are given. Then what we have to do? See here, we have to resist a moment of 25 kilonewton meter. But what we have to do here in working in limit state method, we have to make it as a factored moment. That means we have to multiply the value by a factor which is known as factor of safety. Okay, so here you have to multiply it by a load factor. Okay, load factor of 1.5. In working stress method, whatever bending moment was given to you, we can directly use that value. But since it is a modified method, so we have to apply a load factor of 1.5. Okay. Sometimes here it is directly, it may be written that find the area of reinforcement if it has to resist a factored moment of 25 kilonewton meter. So in that case, this factor has been already multiplied. Okay, in that case, no need to multiply it again. If you can see if you can see the line is, if it has to resist a factored moment of 25 kilonewton per meter, so in that case no need to multiply the value again by 1.5, because that has been multiplied already before. Okay, so now here it is not mentioned, therefore what we have to do, we have to make it as a factored moment. That means we have to multiply the value by some factor which is known as load factor. So here, according to IS 456, we have to multiply it by 1.5. Load factor will be 1.5. Okay, so we have got the factored bending moment. Then what we have to do? Factored bending moment equal to moment of resistance. This we know that from before also we know that moment of resistance is nothing but the factored bending moment. So we will use this formula from IS 456. This formula is given in IS 456. Have you got this formula, all of you? All of you, please open your IS 456. Go to page number, I think it is 96 or something like that. Yeah, go to page number 96 of IS 456. You will see this formula. Moment of resistance is this formula. Okay, moment of resistance is by this formula. So we have to use this formula, moment of resistance. Okay, so can anyone tell me why we are not using this formula? Anyone have any answer why we are not using this formula? Because both are the equations for moment of resistance. So why we are not using this and we are using this equation? Why? Can anyone tell me the answer? Can anyone tell me the answer why we are not using this equation? Emulim. Anyone have any answer why we are not using this, the second equation, Emulim? Why? Anyone?
Because we can find the value of XU max.
Okay. Any other answer? Any other answer? Shiroda, why we are not using this equation, Emulim? Benison, Oinam, why we are not using the equation of Emulim? Less than limiting value. No, that is not the reason. Okay, to Achumi. Sheila, do you have the answer? Anyone? Just think it before. We have solved it so many times. We have used this equation so many times. But now also you are not able to answer this question. When we will use this equation? In which condition we use this mu lim? In which condition we will use this mu lim? In which condition we use mu lim, limiting moment of resistance? In which condition? Yes, over reinforced. So now we are designing the section. That means we have to find out the area of steel. So over reinforced section, we can't consider that our section is over reinforced because it is not desirable. So this is the equation for under reinforced section. Therefore, we have to use this equation only, not this. We can't use mu lim because it is the equation for over reinforced section. That's why we can't use this equation and we have to go for under reinforced equation. Okay, this equation is for under reinforced section, so we have to use this equation only. Every time, whenever you don't know what is the type of section while designing a beam, always you have to assume that your beam is under reinforced because that is the most preferred section. Okay, over reinforced section is never desired, never preferable. So always we will go for under reinforced section. So we will use the equation for under reinforced, and that's why we will use this equation mu equal to 0.87 FYAST. Okay, please remember this. Okay, please remember these small points. Otherwise, in exam you might use mu lim. So in that case, your whole numerical will be wrong. Okay. So if you use this equation, only unknown is AST, and I hope with your calculator all of you can find out the value of area of steel. Yes or no? Can you find out the value of AST from this equation? Okay, so after getting the value of AST, what we will do, we will find out the depth of neutral axis. Okay. Okay, depth of neutral axis. All of you know the formula of depth of neutral axis. This is the formula. So then after that, what we will do, we will find out the limiting depth. Then we can see the values. Then we can see the values of XU and XU max. Okay, so from these two values also you can see that our assumption was correct. Is it? From these two values, from XU and XU max, you can see that since depth of neutral axis is less than the limiting depth, that's why we can say that the section is under reinforced. So we can say that our assumption was correct. See here, since XU max is greater than XU, hence the section is under reinforced and hence the design is okay. Okay, so here all of you remember one thing. Okay, so all of you remember here for the same problem. Okay, so for the same problem, if you are assuming this as an under reinforced section, okay, so after getting the value of AST and then after calculating the value of XU and XU max, if you are getting this value as over reinforced, so that means what you will conclude here, that since the section is over reinforced, therefore it must be redesigned. Okay, your comment will be that one. Your design will not be safe since in a different problem, I'm asking you, I'm saying in a different problem, if you are getting XU max is less than XU, then in that case your section will be over reinforced and your design is unsafe and you have to redesign the structure again. Okay, you remember these things whenever you are designing a section. So while designing, if you are getting that the section is over reinforced, so always your comment will be, since the section is over reinforced, so it is unsafe and we have to redesign the section. Okay, that comment you have to write down. And in the section, in the question, if it is again it is mentioned, if you have to redesign, okay, if you have to redesign, then what you have to do again, you have to change the section. That means you have to change the dimension of the section and you have to do the calculation again. Okay, so I hope all of you have understood this problem. Yes or no? Okay. Okay, so all of you, please solve the same problem. Okay, solve the same problem by taking this as M25. Okay, M25 and FE500. Okay, and this factored moment. Okay, so you write down factored moment of 30 kilonewton per meter. 30 kilonewton meter. All of you solve the same problem with the factored moment. Here in the question, you can write down the question. Same question. First line is same. Find the area of reinforcement required if it has to resist a factored moment of 30 kilonewton per meter. 30 kilonewton meter, and here you use M25 and Fe500. M25 concrete and Fe500, and you solve the question. All of you try the problem now. In the same problem, factored moment of 30 kilonewton meter, and grade of concrete is M25 and steel is Fe500. All of you solve the question now. All of you solve the question now. Okay, so this class will be over by 5 minutes. Then you join with the same link. Okay, join with the same link. And one thing for every class, okay, for my every class in this semester, you can join with this link only. Okay, so from next time I will not share any link in your group. So whenever I have class, just join with the same link. Okay, whenever I have class, all of you please join with the same link. For this entire semester, my link will be same. So whenever I will have class, all of you please join with the same link. I will not share the link again and again. Okay? Okay, so all of you solve this problem now. Anyone got the answer? Anyone got the value of AST? In this question, your factored bending moment will be 30 into 10 to the power 6. Okay. And from this equation, you have to find out the value of AST. Find out the value. Anyone got the value of AST? Anyone? Benison, Wilson, Shiroda, anyone? Area of steel? No one got the answer. No one got the value of AST. Anyone get the answer? Please write down in the chat box.